This video is about acids and bases and how to classify them. So first thing is that acids are things that donate hydrogens. And bases are the opposite. Okay, acids and bases are kind of like a yin and a yang. So acids will donate and the bases will accept those hydrogens. Okay. The easiest way to tell if something is an acid, and very straightforward, is if the H is in the front of the compound, like HCl is hydrochloric acid, or H2SO4. Both of those have H's in the front, so those are acids. Versus a base might be something like NaOH. Here the H is in the back. Or NH3, the H is also second. So those are two quick ways of how you can tell right away if it's an acid or a base. So there are these things called monoprotic acid. Mono just means one, so that's one hydrogen that is donated. So an example of that would be like HCl. Second one we have here is called a diprotic acid. Okay, di means two. So that's two hydrogens to be donated. An example of that would be like H2SO4. That's sulfuric acid. Okay, or we can have triprotic acid, which just means that there's three H's to be donated. So that would be like H3PO4. Okay, so those are just some quick types of acids. The main focus of today is conjugate acids and bases. So a conjugate acid is basically what happens when a base accepts the hydrogen. Okay, so the acid gives it to the base. That's a conjugate acid. A conjugate base is when an acid donates the H. And we'll see some examples down at the bottom in a second. Last definition before the examples here is amphoteric. Okay, if something is amphoteric, that means it can be both an acid and a base. Okay, it can do both. It can give and receive. So things like H2S or H2O, that's water, right? The H is in the front, which means it's an acid, but it can also accept an H and become H3O+. So it can give and become OH-, or it can accept and become H3O+. So it can gain an H or lose an H. That's amphoteric. Another quick amphoteric example is HSO4 with a minus charge. So this H can actually accept and become H2SO4, or it can donate and get rid of that H and become SO4 2-. Okay, you guys don't have to worry about the charges. You just have to look at, is it gaining an H or losing an H? So in the homework problems and in these kinds of problems, what we're going to have to do is label which one's the acid, which one's the base, which one's the conjugate acid, and which one's the conjugate base. So let's look at this first problem here. So when looking at these problems, we really need to just look at the left side and the right side separately. So the acid and the base will always be on the left side, and then the conjugate acid and the conjugate base will be on the right side. You just have to decide which one's which. So looking at this first thing, we have H2CO3. The H is in the front, that's an acid. Second one, we have OH-, H is second, so that is a base. That means that the H2CO3 is giving a hydrogen to the OH-. Okay, it's giving it a hydrogen. Acids give to bases. And we can see that's the case because when we look at the right side, that kind of shows you what happened. So over here, we have one H on the right side, and on the left side, we have two H's. So you can see it had two H's, and now on the right side, it only has one H. Okay, that shows that it had an H, got rid of it. That means it is an acid. So these things are connected. Okay, they both have that carbon and oxygen in them. So If that's the acid, that means this must be its conjugate base. The acid is always paired with a conjugate base, and the base is always paired with a conjugate acid. So that means if OH is the base, that means H2O is the conjugate acid, or the conjugate acid. Okay, let's look at another example. So we have H2O and Cl minus. The H is in front on the water, so that must be the acid, and the Cl must be the base. Now we're going to look up how they match up on the other side. So Cl was just Cl, and now it's HCl. So it was a base. Now on the right side with the H is going to be the conjugate acid. We have H2O, and it lost one of its H's, so now it's just OH minus. So it was an acid, now it's a conjugate base. So acid pairs with conjugate base pairs with conjugate acid. All right, now let's look at a harder example. So in this one, there's an H in the front of both of them. So which one is the acid? You really can't tell, so what you need to do is look at the right side and see what happened in this equation to determine which one gave. So we have H3PO4 on one side and H2PO4 on the other side. And then we have H2O on the left side and H3O on the right side. So you have to ask yourself, who gave to who? Did the H3PO4 give to the H2? Or did the H2 give to the H3? Well, when you look at this PO4, it had 3 H's, and now it only has 2 H's. So that means that the HPO4 gave to the H2O. Whoever is giving is going to be our acid, and whoever is receiving is going to be the base. So this one's the acid, and this one's the base. Okay. The acid is always paired with a conjugate base, and the base is always paired with a conjugate acid. All right, last one here. If you want to pause the video and try it for yourself, see if it's making sense to you, but I'm going to go through it as well. So we have H2PO4 becomes HPO4, and then HSO4 becomes H2SO4. So who gave to who? Well, the H2PO4 gave one away, because you can tell on the right side it only has one H. So it must have given one away. So that means the H2PO4 is the acid, the HSO4 is the base. The acid is always paired with its conjugate base, and the base is always paired with the conjugate acid. And just kind of as a side note too, it's not always in a particular order. The second element could be the acid, and the first element could be the base. They kind of switch around. So you just have to really look at the problem and see what's going on.